Electron configuration. So let's practice writing noble gas configurations. For selenium, first one, which is right over here. So what can help when an exam or a quiz is given to label the periodic table as much as your memory allows. For example, I know that all of these periods are energy sublevels 1 through 7. This is my S block, this is my P block, here's my D, and here's my F. I know that D starts at 3 and F starts at 4 because at energy level 3, you have 3 orbitals obtaining that energy level, S, D, and P, and at energy level 4, you have the F orbitals as well. Okay, so first selenium is right here. The noble gas that comes before it is argon, so I have argon. Then I go all the way here, I have 4s2. Then I have 3d10 and 4p, 1, 2, 3, 4. Next one is, that doesn't look like a 10, 3d10, 4p4. Now the next one is chlorine, which is over here. So the noble gas before that is neon. And then you have 3s2, 3p5. Then we have strontium. So we're over here. So my noble gas is krypton. So I have Kr. And then 5s2. And that's it. So now let's look at these. Identify the specific element that corresponds to each of the following electron configurations and indicate the number of unpaired electrons for each. So now here's a new little lesson. Okay, well, argon. So I'm here. Okay, all of the stuff in the top is filled. 4s1, 3d5. 3d5 is 1, 2, 3, 4, 5. Okay, so I have Mn. Well, that's actually not necessarily the case. So if we look at the electron configuration for chromium, it's argon, 4s2, 3d4. So I have a 4s orbital that's paired, and then I have my 5 3d orbitals and 4 electrons. So this actually doesn't stay this way. This is really unstable because the electrons would rather have an electron in every single orbital before pairing. So based off of the different principles that we've learned, we know the Aufbau principle, filling the energy level before another one, the Hund's rule, and Pauli exclusion principle, putting one in before pairing, which is what we've done. However, this is completely alone. So what actually happens is the 4s gives the electron to the 3d to stabilize chromium, and the actual electron configuration of chromium becomes argon 4s1 3d5. So this is chromium. Next one, we have 5s2 4d10 5p4. So 5s2 we're here, 4d10 we've passed all of this, 5p 1 2 3 4, so we're at Te. Now one more thing that I want to mention just to practice. What if I asked for the electron configuration of Fe+? So just Fe is argon, 4s2, 3d, 1, 2, 3, 4, 5, 6. Here you do not have to worry about the electrons rearranging because there's an electron in every single orbital. Now, when it's plus, it's not going to go from 3d because 4 is the higher energy level. So when you have an ion, it's going to go from the largest energy sublevel. So here for iron plus, it'll become argon 4s1 3d6.